Today we're going to look at u substitution involving rational functions, so fractions. So if we look at this first example, we're going to integrate 8x minus 12 over x squared minus 3x plus 4 to the fourth. Okay. So first thing we want to do is take what's on the bottom, and we always want to move it up. Okay, so this part has the exponent on it, so this part's going to be u. So I'm going to write that first. And when I'm moving it up, I'm going to make the exponent negative. So this is the part that's left over. Okay, this is what I'm choosing for u. So the leftover part, first I'm always going to take out the GCF. So I can factor a 4 out of this. So I'm going to bring a 4 out in front of the integral. And then just off to the side of u, I'm going to write what's left. Okay. So what I picked for u was x squared minus 3x plus 4. Now I need this part to match du. So if I take the derivative of this, that's 2x minus 3. This and this match. So I don't need to add anything in or multiply anything in. So I can get rid of that. Okay. And now I'm ready to integrate this. Okay. So you can switch it to be a u. Then we're just going to do the antiderivative. So we're going to add 1, divide by that new exponent, and I'm going to go ahead and just divide the 4 that's already out here by it. So that will give me negative 4/3 u to the negative 3 plus c. Okay. Then the last thing I need to do is take this negative exponent, move it back to the bottom, and I also need to replace the u back with the x squared minus 3x plus 4. So our final answer here is going to be negative 4 over 3 times x squared minus 3x plus 4 to the third plus c. For our next example, we've got one similar. So now we're going to integrate 6x minus 9 over 2x squared minus 6x plus 1 cubed. Okay, so again, this part's going to be u. So first I need to move it up. We can't ever do the derivative or the antiderivative when something's on the bottom. So I'm going to move it up. That makes the exponent negative. This is what's left over. I can GCF a 3 out of that. So I'm going to take the 3 out of this. What I'm left with is a 2x minus 3. So this needs to match du. So now I'm going to take the derivative of that. So that's just 2 times 2, 4x to the first, minus 6x, and then the 1's going to go away when we take the derivative. Okay, so these two need to match. So what I need to do is multiply this one by 2 so that it'll give me the 4x minus 6 to match. So since I'm going to multiply by 2 in here, I need to divide by 2 out here to counteract it. Okay. So now that this matches, I can ignore it, and then I'm ready to integrate this. So this is going to be 3/2 times u to the negative 3. Okay, so to do the antiderivative, we're going to add 1. That's going to make our new exponent negative 2. So I'm going to divide this coefficient by negative 2. That will give me negative 3/4 u to the negative 2 plus c. And just like on the last one, I need to move this back to the bottom and put the u back in. So that'll be negative 3 times 4, or negative 3 over 4 times 2x squared minus 6x plus 1 squared, and then plus c. Okay, let's look at one with a root now. Okay. So again, this is the part in the square root. So this is what's going to be u. Okay. So square root, remember, is an exponent of 1/2. So I'm going to move it up can change the exponent to a fraction and make it negative since I'm moving up. Okay, so then I just have this 1. So u is going to be 2x plus 1. So this, the extra part, okay, this is what's going to be u. So this is the part that needs to match du. Well, the derivative of 2x plus 1 is just 2. So in order to make this match, I'm going to need to multiply it by 2. So on the outside, I'm going to need to divide by 2. So that would just be 1 over 2. Okay. Now this matches, so I can ignore this, and we're done with this over here. So we're just going to do 1/2 u to the negative 1/2, just replacing that with a u. Then I'm going to add 1, so that's like 2 over 2. So that makes my new exponent 1/2. So I'm going to divide by 1/2. So 1/2 divided by 1/2 is going to give me 1 u to the 1/2 plus c. And then just replace your 2x plus 1 to the 1/2, and you're done. So now in this one, we have a cube root. Okay, so we've got 2x squared over the cube root of 2x cubed plus 1. Okay, so again, the part inside the root is always going to be u. So I'm going to take the 2x cubed plus 1. Cube root would be an exponent of 1/3, so since I'm moving it up, it's going to be negative 1/3. Okay, the x squared, I'm just going to leave it off to the side, but the coefficient, if there's a coefficient of just a single term or a GCF of multiple terms, I'm always going to move that out to the front. So then since u is 2x cubed plus 1, that means du is 6x squared. The 1 will go away when I take the derivative. So this is what needs to match du. So I have to multiply it by 6. So on the outside I need to divide by 6. So that reduces to 1/3. That's u to the negative 1/3, and then I can ignore this now that it matches. Okay. Then we're going to do the antiderivative, so add 1. That's 3 over 3. Divide by your new exponent, which is 2/3. So that's 1/3 times the reciprocal, 3 over 2, which is just going to give us 1/2. So that'll be 1/2 u to the 2/3 plus c. Then put your 2x cubed plus 1 back in.